Okay, hi everybody. So today's PowerPoint is going to go through all of the word problems from the summer packet, number 37 to 38. So here in question 37, let's start by reading it together. The holidays are coming and you decide to purchase new candles to decorate outside with. Since you're trying to save money, you purchase them at the dollar store, but because they're very cheaply made, they burn very fast. After being lit for 2 hours, the candle is 20 inches tall, and after burning for 6 hours, the height of the candle is now 17 inches. So there's a bunch of different parts to this question meant to go in order. Each of the previous questions will kind of set you up for the following ones. So in part A, identify the variables in this problem. The number one mistake that people make is that when we ask you for a variable, they give us a number. That cannot be the case. By definition, a variable has to be something that changes, so it has to be words. So if you go back and read through this problem, you're trying to figure out what are the two quantities that are changing. One of the things that is changing is the time that the candle is lit, and in this case, it's in hours. So our X in this case is going to be the number of hours that the candle burns. Then, depending on how long the candle has been burning, the height of the candle changes. So that's going to be my Y. Spoiler alert, I would say at least 90% of the time in word problems, one of the variables is time. And if the variable is time, that is always going to be your independent variable, which of course would be the X. So once you've identified the variables as being the hours burning and the height, below it's asking you to now rewrite two ordered pairs, X, Y. So since you're telling me that X is time and Y is height, if you go back to the original problem, if you have a matching value of a time and a height, that's going to give you one of your ordered pairs. And so it turns out after 2 hours, 20. Then after 6 hours, 17. Here in part B, you're now going to use your ordered pairs to find the slope of the line, and then you're going to find that magic linear equation, y equals mx plus b. So once you have 2 points and you want to find the slope, you hopefully, of course, remember the formula for slope, which is y2 minus y1 over x2 minus x1, and of course m is always used to denote the slope. In this case, it doesn't matter which point is x1, y1, which one is y1, y2. So you're going to go ahead and subtract 17 minus 20, that's the difference in y's, then 6 minus 2, that's the difference in x's. That's going to give you negative 3 over 4. Normally when you're graphing these, you do leave your slope as a fraction, but because it's a word problem, it makes sense to actually convert that to negative 0.75 because you're talking about part of an hour. So negative 0.75, notice that it's negative here. Why? Because the candle is burning away. The longer you have it lit, the more wax kind of drips off and the shorter the candle is going to get. So that's our M. Now y equals mx plus b. So that's the equation that we're going to start with. In order to find a y equals mx plus b, you always need the slope, which we just found. And then you need some ordered pair, xy. Luckily, we have not just one, but we have 2 pairs to choose from. So I'm going to go ahead and choose the first one. Remember, it would not matter which one you pick. You're going to plug the 20 in for the y. You're going to plug in the negative 0.75 that you just found. You're going to plug 2 in for the x. And then the b is, of course, what we're looking for. So 20 equals 2 times negative 0.75 is negative 1.5 plus b, which means that b is going to be add 1.5 to 20, which means that 21.5 is going to be your b. So now that you found your slope and now that you found your y-intercept, you're going to put them together to have the magical equation that you can now use for the entirety of this problem. So y equals negative 0.75x plus 21.5. That's the equation that we're going to use going forward, and then it asks you additionally to explain what each thing means. So what does the slope represent in the context of this problem? The slope is negative 0.75, which means that how much of the candle is burning away each hour. So 0.75 of an inch is burning away each hour. What does the y-intercept represent? Well, the y-intercept is 21.5, which of course is the original height of the candle. So when you purchased the candle from the store, it was 21.5 inches tall. So in order to answer the rest of the questions, we're going to continue to use the information that we found in sections A and B. So when they ask you how tall will the candle be after 10 hours of burning, the whole point of finding y equals mx plus b was now we can use it for all of these other parts of the problem. So y equals negative 0.75 plus 21.5. How tall will the candle be after 10 hours of burning? So 10, notice, is a time value. If you go back to the very first question, you said that time was x. So you're going to go ahead and plug 10 in for x. So negative 0.75 times 10 plus 21.5. Go ahead and plug that into your calculator, and it turns out that the height of the candle after 10 hours of burning is going to be 14 inches. And again, hopefully that makes sense that the candle after 10 hours of burning is shorter than it was when you purchased it. That's because the slope is negative, and again, that's because the height of the candle is burning away the longer that it's lit. Question D, if the candle is 8 inches tall, how long has it been burning? So now they're giving you a height. If you go back to the original question A, you told me that height was a y value. So now you're going to plug in that value for the y. So 8 equals negative 0.75x plus 21.5. Subtract the constant from both sides. 8 minus 21.5. That is going to give you negative 13.5 equals negative 0.75x. Divide both sides by negative 0.75. It's good news that both sides are negative because, of course, the negatives cancel. And it turns out that you get that x equals 18 hours. For these word problems, keep in mind a little bit of common sense. The height of a candle has to be positive or else it's burnt away. The amount of time that the candle has been burning has to be positive because negative time is not a thing. So very important to kind of keep those two things in mind. Here in E, they're asking you for the x-intercept of this problem. So earlier on, we found the y-intercept. So not only is the y-intercept always the b in y equals mx plus b, but if you're trying to find it on its own, please remember that you always find a y-intercept by setting whatever the x in the equation is equal to 0. And if you were to go back to the original problem, you would see that if you put a 0 in for x, you're going to get a y-intercept of 21.5. So to find an x-intercept, you're always going to set the y equal to 0. So in this case, we're going to set y equal to 0. Subtract 21.5. Again, the fact that it's a double negative is a good thing. Divide both sides by negative 0.75, and it turns out that you get x equals 28. We'll go ahead and round it to 0.7. Always give a unit when it's a word problem. So in this case, 28.7 hours. So after you have lit your candle for 28.7 hours, all the wax is going to melt and you're no longer going to be able to use it. Okay, so here we are for parts F and G, and we're actually going to do part G first because it's talking about the same candle, where question F is talking about your friend's candle. So of course, that equation we found earlier, that's the same equation all the way through, negative 0.75x plus 21.5. Here's the thing, trying to graph that by hand is actually relatively messy. You're trying to graph decimals. Even if you converted them to fractions, it's still going to be a little bit of an issue. Obviously, if you had a graphing calculator, that would be much simpler. So if you are asked to graph something like this by hand, you can kind of cheat a little bit by just focusing on the important points, which in this case is going to be the y-intercept, where the graph crosses the y-axis, and the x-intercept, where the graph crosses the x-axis. Luckily for us, we actually found these values earlier on. When it comes to a scale, maybe you knew it, maybe you didn't, but you don't have to choose the same scale for both of these. If you go back to the previous problem, the y-intercept is 21.5, which means that on the y's, we're going to have to get up to 21.5. So I'm going to actually go ahead and count those by twos. 4, 6, 8, 10, 12, 14, 16, 18, 20. And then the next one would be 22. So if you're trying to graph 21.5, that would be between 20 and 22, obviously closer to 22. So a little hard to see there, but there's my y-intercept at 21.5. Then if you go back and look at your x-intercept was 28.7 hours, which again is a decimal. So on the x-axis, I have to get up to 28.7, which actually means I have to get relatively close to 30. So I'm actually going to count these by threes. that's going to mean that when I get all the way over here, that's going to be 30, which means that the previous one is going to be 27. So if I'm trying to graph 28.7, again, that's between 27 and 30, a little bit closer to 30, although it's a little hard to tell. So once you know your x-intercept and your y-intercept, you can just basically connect them. And even though the graph isn't going to be perfect, it's certainly going to show you that for every hour that goes by, the height of the candle is going down, which is why there's a negative slope. Also notice that in this case, the graph does not extend past the x and y intercept. Why is that? Well, obviously the height of the candle cannot get any larger than it was when you purchased it. Obviously, once the height of the candle is 0, it can't burn away into the negative. And same thing for the times. You can't have negative times. And then once you reach 28.7 hours, that means that the candle has burned away. And so as far as you're concerned, the time has stopped. So very important that you're not only able to find a y equals mx plus b, but that you are able to apply it in the context of this problem, which means it does not go to infinity. It has a clear start and a clear end. Looking at question F, you have a friend Jay, and so he has a different candle. He realizes that his candle is going to be 10 inches tall after it has been burning for 7 hours. He also knows that the height has been going down 2 inches per hour since he first bought and lit it. How tall was the candle when he purchased it? So because Jay has a different candle, that means he has a different y equals mx plus b. The x and the y are still the same though. The x is still going to be the time that the candle is burning, and the y is still going to be the height of the candle. And if you read carefully about what Jay knows, he knows that after it's been burning for 7 hours, it's exactly 10 inches tall. In addition, he realizes that the height has been going down 2 inches per hour. So anytime there's a change, that is of course the slope. And because the height is going down, that's going to give us a negative slope. So notice y equals mx plus b, we know the slope m, we know some ordered pair xy, so we're able to solve for b. Of course, b is the y-intercept, which in this case is exactly what we're looking for, how big the candle was when he purchased it. So 10 equals negative 2 times 7 plus b, negative 14, add it to both sides, and turns out that this candle was 24 inches when Jay purchased it. So again, notice that even though this was a different candle, a candle still burns in a similar fashion, no matter how tall it is when you purchase it, which is why it's yet another y equals mx plus b. Here in question 38, we're talking about not just one linear situation, but we're talking about 2 linear situations. Anytime you're talking about 2 equations in 2 variables, the magic word is a system of equations. That means you have more than one y equals mx plus b, or they don't have to be linear, which we'll see as the year progresses. They can be more complicated. So you have Mr. Brady and Miss Green, and they basically both have pools. They're both 4 feet deep, and they need to be refilled every spring. Mr. Brady starts with 3 inches of water at the bottom, and he adds water at 3 inches per minute. Miss Green starts with 6 inches of water and adds water at a rate of 2 inches per minute. Before I even attempt to answer this question, I'm going to hopefully notice one big glaring thing here, the fact that the pools are 4 feet deep, but everything else is given to me in inches. You cannot solve a problem if the units do not agree. So since everybody else is inches, and this is the only one that is in feet, I'm going to, of course, hopefully remember that there are 12 inches in a foot, which means that 48 inches is the total depth of each of these pools. Okay, so in part A, write an equation for each person representing the amount of water in the pool, y, as a function of time x that has gone by in minutes. So again, notice that we're only talking about minutes because it's not going to take that long to fill the pool. Unlike the previous problem, I'm telling you what the variables are as opposed to you having to guess them. So for Mr. Brady, if you're trying to do y equals mx plus b, then your m is how fast the water level is changing. And if Mr. Brady is adding 3 inches per minute, that's going to be 3x. The b is the y-intercept, and because Mr. Brady is starting with 3 inches of water, turns out it's going to be 3x plus 3. Miss Green, she is filling her pool at 2 inches per hour, and she is starting with 6 inches. So they each have their own separate y equals mx plus b. Question B is only specifically talking about Mr. Brady's pool. So Mr. Brady's pool, that means you're going to use his equation. When they're giving you a value of time, they're giving you a value of x. So y equals 3 times 10 plus 3, which means that after 10 minutes, 33 inches are going to be present in Mr. Brady's pool. Conversely, in C, they're talking about Miss Green now, and now they're telling you exactly how much water is there. So you're going to take Miss Green's equation, and you're going to put a 20 in for the y. Subtract the 6. Turns out that 7 minutes into this process, Miss Green will have exactly 20 inches of water in her pool. Again, those two equations are going to be used throughout. So here in part D, after 12 minutes, what percentage of Mrs. Green's pool is full? So this is a two-part question, so you have to make sure you do 2 steps. So first of all, after 12 minutes, so for Mrs. Green's equation, that means that x equals 12. So if you put 12 into her equation, you get y equals 2 times 12 plus 6. That's going to give you 30 inches. What percentage of her pool is full? So a percentage is always the part over the whole. So 30 inches are currently filled. The whole is how much water fills her pool to begin with. And remember, it's 4 feet, but more specifically for us, it's 48 inches. 30 divided by 48. You're going to go ahead and get 0.625. And of course, to make that a percentage, you're going to move the decimal point 2 places to the right, which means that her pool will be 62.5% full after 12 minutes. If they both start filling their pools at the same time, whose will be filled first? So again, what does it mean for the pool to be filled? It means that you have to have 48 inches all together. So take each of the equations, set them equal to 48. So for Mr. Brady, 48 equals 3x plus 3. Subtract the 3, divide by 3, takes Mr. Brady 15 minutes. And again, that's B for Brady. Mrs. Green's pool, 48 equals 2x plus 6. Subtract the 6. 42 divided by 2, 21 minutes, and that's G for Green. So whose pool is going to be filled first? Mr. Brady's. Only takes him 15 minutes. If Mrs. Green begins filling her pool at 1:45, what time will it be full? So it takes her 21 minutes. If she starts at 1:45, that means that her pool is going to be filled at 2:06 p.m. Okay, and finally what we would like to know is there a time that both pools have the same amount of water? Now, of course, the goal is you're going to fill each pool, which means they'll eventually both have 48 inches of water, but one is going to be filled up sooner than the other since they're increasing at different rates. So hopefully you remember from a couple of slides ago, when you have 2 equations in 2 variables, that is called a system of equations. So there are 3 different ways to solve a system. The one that we're asking you to show here is the graphing. If you're trying to solve a system by graphing, you're of course trying to see where the 2 graphs will meet. And remember that when you're solving by graphing, the graphs can either meet exactly one time, which they do in this case. They can meet all the time, which means there's infinitely many solutions, or they cannot meet at all, which means that there's no solution. So in this case here, graphing, the nice part about graphing is that it shows you the big picture, what's happening over the whole period of time. The bad thing about graphing is that it's the least precise and it takes the longest amount of time. So I have graphed each of the lines for you here already because it's a little hard for me to do with my stylus. So notice first, we have Mr. Brady's equation, y equals 3x plus 3. So notice that the graph is starting at the y-intercept of 3. Then you would go up 3, right 1, up 3, right 1, up 3, right 1, and as many times as would fit on the graph. Then, of course, for Mrs. Green, y equals 2x plus 6. You're going to start at the y-intercept, which in this case would be 6. You would go up 2, right 1, up 2, right 1, up 2, right 1, and you would ultimately see that those 2 lines would intersect at the point 3:12, which means that 3 minutes after both people start filling their pool, they will both exactly have 12 inches of water in it. The other thing that's nice about seeing the graph, so if you take a look here, you can clearly see that Mrs. Green, y equals 2x plus 6, has more water in her pool to start at 6 inches compared to Mr. Brady, who only has 3 inches to start. Then you can see that because Mr. Brady is increasing his water more quickly than Mrs. Green. You can see that at some point the red line overtakes the blue line. That's where it changes from being underneath to being above. So you can see that ultimately, even though Mr. Brady started with less water, he's going to fill his pool faster because he's increasing it at a faster rate. We now know that the solution to this system is 3, 12. So how would we show that using the other methods for solving systems? Well, other than graphing, the next method for solving a system is substitution. This is the one that's actually, I think, the most useful, but for some reason, students like it the least. So when we're talking about substitution, you're trying to take something from the first equation, and you're trying to replace it with something from the second equation, or vice versa. The best thing about this particular system is because they're both y equals, you can simply assume that this y has to be equal to this y, which means you can just set those equal. Replace one y with the other y, which would then give you the equation here. Subtract 2x from each side, giving you an x. Subtract 3, and that's how you get the answer of x equals 3. You, of course, to solve a system, also have to find the y value, which means you can go back to either equation, plug 3 in for x, again, in either equation, and if you do so, you're going to get a corresponding y value of 12. So 2 different methods so far. The last one is elimination. Elimination is where you aim to get a pair of exact opposites, add them together, and then hopefully eliminate one of the variables. So y equals y equals. In order to get a pair of exact opposites, one of those y's has to be a negative. So I'm going to leave the original equation, y equals 2x plus 6. I'm going to multiply the second equation, everything, by a negative. Then I'm going to add those equations together. Again, the whole point of elimination is that one of the variables should eliminate, which in this case is the y. So 0 equals negative x plus 3. Move the x over, plug it back in to get a corresponding y value of 12. So again, 3 different ways to solve a system, and you are going to have to know how to do all of them. Graphing is the least precise, but it shows you the big picture. Of course, you can also do this on your graphing calculator if you know how to graph the 2 equations and find the point of intersection. And then when it comes to the messier numbers, the ones that are not as easy to graph, substitution and elimination are the way to go.